Hello everyone, welcome to Java Data Structure Algorithm interview question series. In each video, we will tackle an important interview question of DSA. I will teach you each and everything in detail, how to build its logic, how to make a pseudocode, how code run in backend, how to make code in a code editor. I will teach you each and everything in detail. So watch till the end. And you can find DSA interview question series playlist link in description box and practice other questions also. They will help you to build logic. And for this video, our question is this. So let's solve it. So our question is, we have to invert our binary tree. So binary tree is given, that is 1, 2, 3, 4 and 5. 1 is our root node, 2 is its left child, 3 is its right child. 4 is left child of 2 and 5 is right child of 2 and 3 has no left or right child. Okay, so we have to invert this. So invert means you can imagine it as a mirror. When we see ourselves in mirror, our left become our right and our right become our left. So when we place a mirror here, so what will be its output? This 2, which is its left child, it will come here and it will become its right child. And 3, which is its right child, it will come here and it will become its left child. Same with this 4 and 5. 4 will become its right child and 5 will become its left child. I am seeing this mirror example so that you can understand it very well. Okay, so we are placing this mirror. In easy words, we can also say this that we are swapping our nodes. Yes, we are swapping and this will help in our code. 2 is coming at 3 place and 3 is coming at 2 place. 4 is coming at 5 place, 5 is coming at 4 place and 1, it is our root node. So there is only one root node, that's why it will come here only. So when we invert this, what will be our answer? 1 will be here only because there is only one root node, that's why this 2 will come here. 3 will come at 2 place. Now 4 and 5. So 5 will come at 4 place. Okay, so 5 will come here and 4 will come at 5 place. This is here and 3 has no left or right child, that's why empty. And don't think that this 4 and 5 will become while inverting this 4 and 5 will become its 3 left and right child. No, because we are inverting this whole subtree. Okay, so this whole subtree will invert in this way and this 5 and 4 will be left and right child of 2 only, not 3. So I hope you understood. So now we will make our code. For code we are doing swapping, so we have to write our swap code. So here we are using recursion. So I have taught you, whenever we use recursion, we have to make a function or a method. Okay, and the whole code is written within that function or method with base case. So I have taught you in very detail in our recursion tutorial. If you have not watched, you can get its link in description box. It's in Hindi, and if you want me to make in English, you can comment below. And we have practiced recursion very well with interview questions. So you will get recursion complete tutorial link in description box. So we have to make a function. So we will write function public static tree node. And I will tell you why we are writing this tree node. We have learned in our binary tree tutorial, but I will tell you once again in our code editor. Okay. So this tree node we are making a class and we will write its properties there. Okay. So now our name of this function is invert tree. Okay, and then we will give tree node as input root. Okay, so now we have to write our base case and our code. So our first condition will be if no root is present, means this no root is present. So what we will do? If no root is present, that means there is no binary tree. Okay, it's empty, we have no binary tree, so we can't do anything. So you can return from here null. Okay, so for this we are writing root. If root is equals to null, then you can return null. Okay, and the next condition will be, that means in else part, that means we have our binary tree, so we have to swap our nodes. So for that, so for swapping I have taught you one before also, but once again I'll tell you. So for swapping I have taught you before also, but once again I'll teach you. So how to swap we have to swap our 2 and 3. Okay, so this 2 will come here and this 3 will come here. So for swapping, what we will do, we will need a temporary place. Initially it will be empty place. Okay, empty. So this 2 is here and this 3 is here. We have to swap. So now this 2 will go here at temporary place. Okay, which was initially empty. Now 2 is here. So this place is now empty. 2 is removed from here. So now this place is empty. So now this 3 will come here, which is empty place here. So now this is empty. Okay. So now the 2 which is present at temporary place will come here at 3 place, which is empty. So now 2 is here. So now temporary is empty. So now we have finally swapped our 2 and 3. 2 here and 3 here. So I hope you got this. So now we will write this in code. So for code we need our temporary place. This is our tree node. If you are not getting this tree node, I will show you in our code editor. This is our class and we will write its properties there. Its left child, right child, its value. We have to write whole this. So now we have take our temporary and we want our root dot left. Root dot left will go at temporary place. Okay, so now we are writing this only. Root dot left. You can read it from backward. Root dot left value has came to our temporary place. Our temporary place to here. Now the next thing will be 2 place is now empty. So now we have our empty place. So root dot left. This is empty now. So now this right root dot right will come at 2 place, means at root dot left place. So we are writing this only. So we will call this our function because we are using recursion. So we have to call invert tree, and in this invert tree we will call root dot right. Okay. So now finally when our code editor will call this function, so now our root dot right means 3 will come at root dot left place. So now our 3 place is empty. So now we will again call this invert tree, and now the value root dot left value which was present at temporary, now this will come here at 3 place. So we are writing this root dot right. If you don't know how to read this or how to write its codes, you can read it from backward. We are putting this temporary value, that is 2, at root dot right place at 3 place. So now we have swapped our whole binary tree, and now you can return from here our root. So now for swapping, this much code will be only there. So now we have to make a function for printing this. Okay, so for print only we have to write. So for print we have to make a new method or a function that will be public static void print tree. You can change its name also. Tree node and root. So now we have to write our first condition, that will be if root is not equals to null, means there is value present. So then you can print our values. So for printing I am using in order traversal. So if you don't know what is in order traversal, a traversal is a method to visit each node in a particular order. So in order traversal, how to visit our nodes? We have to visit each and every node in our binary tree. So in order traversal, we have a order, which is first we have to visit our left node, then our root node, and then our, I'll write here root node, and then our right node. Okay. Here this is left node, root node, then we have to write our right node. So we will start from here. We have to visit each and every node in our binary tree. So we will start from here. First is left. This is our root node, so we have to visit our left node. This is our left. After swapping we have to print. That's why I am taking this. If we have to print this, so we will take this, but we have to print after swapping. That's why I am taking this one. Okay. So first we have to print our left node. This is root node. We will go here. This is our left node. Okay. So till bottom we will visit. Is 3 having any left or right child? No, we don't have. That's why we can print this 3. So this 3 will be printed. We are visiting from here. First is left. Then we have to print our root node. Then right child. So this is our root node. We are going here. This is our left. Then we have to visit again left. But there is no left. That's why we are now printing our root node. Then we will visit our right. Is there any right child? No, there is no right child. So now we will again go from here. Now here. So now left is completed. Yes, we have printed all left child. So now our root node. Left we have printed. Now root node. Now we will come here. Right. In right we have to again visit our this node. We have to go till bottom when we get our null value. Till that. Now we are going here too. Now again left, bottom, null, yes. So now we have to stop. So now left child, there is no left child, there is null. So now we have to print our root node, that is 5. So now we will go. Our left work is done, our root work is done. Yes, we have printed root node also. So now we have to go our right child. Our right is null. So okay. Now we have to again go from here to here. Left child work is done. Yes, it is done. Now this is our root node. Okay. For 2, this is root node, this is left and this is right. Okay. So now left is done. Yes. Now root 2. Now our right child. So for going to right, we have to visit our left also. Left is null. Yes, null. So now we can print this root node. We have to visit right also. Is there any right child? No, there is null. Okay. Now we will come here, here, here. We have printed 2. Yes, we have printed 2. Now we have printed 1. Yes, we have printed 1. Now end. Okay. So we have printed all our nodes. Means we have done our in order traversal. So I hope you understood. I have taught you each and everything in detail in our binary tree video, our post order, pre-order traversal, in order traversal. So you will get its link in description box. I hope you are following our Java DSA complete course series. It's in Hindi. If you want me to make in English, you can comment below and you can get its complete playlist link in description box, and you will get each and every topic link also in description box. So for this in order traversal, we have to write its code. So for writing this, so we are using recursion here. So we have to call this. For writing this, we are calling this print tree. Now in our in order traversal, first is our left. It will print our left child. Then it will go to our root node. Then it will print our right child. So we have to write in this way only. Okay. So first is root dot left. Then we have to print system dot out dot println. Then root dot value. And this is space. And then we are again calling our function for our root dot right. Left, root, right, left, then our root, then our right. So after writing our whole code, we have to call these functions from our main function. Okay, so we have to write that code also. So I'll tell you that also. Okay. So public static void main, here is string args. Okay. So now we are making our binary tree. Why? Because first we have to tell our code editor, na, this is our binary tree. Then only it will swap or invert this. So for initially we have to tell our code editor. So for telling our code editor, we will write here tree node root. So we are telling our code editor that our tree node root is 1. Its value is 1. Then we will tell its left. So our root dot left is, so for root dot left, we have to tell our code editor that this is our root node, which is 1. Its left child is 2. So we have to write this root dot left is new tree node, that is 2. Now root dot right. that is 3. Now root dot left, that is 4. So root dot left, the same we will write here, new tree node, and that is 4. And then root dot left right, that is our 5. So now we will invert our binary tree. So for that we have to call it. For that we are writing tree node, that is inverted root. I'm writing this, you can directly call also. So invert tree root. Okay. And now we have to print. Okay, we are using system.out.println here only, so that's why I have written void. And if we want to call from here, then we have used int, and we have to return from here, but we have written system.out.println here only. So now we will only call print 3, now inverted root. So we have written our complete code. Now we will write this in our code editor and we will see our output is correct or not. So for code, we are making a public class binary tree inverter. Now we have to make a class, that is our static class. Its name is tree node, and within this class we will write its properties. So what will be our binary tree properties? First will be its value. Each and every node has its value, and each node had its left and right child. So for that we are writing its value. Our value is int type, integer type, that's why we have written int. This tree node is its type. Left is our tree node, so that's why we have written its type, and right is our also tree node, that's why we have written its type. Now we will make its constructor. So for constructor we have written int value and this value. Okay, so this value is for our current node. When we are making our first node, that is our root node, so this value will be 1. When we are making its left child, so then its value will be 2. When we are making its right child, then its value will be 3. So that's why. And now we will make our binary tree so that our code editor can invert this. So our binary tree, we have written it in its some main function. So tree node, its type is tree node. Our root, new tree node, and its value is 1. Our root node is 1. Yes, it's 1. Its left child is 2. So that's why we have written root dot left is 2. Then our root dot left is means root's right child is 3. That's why we have written 3. Now our 2, that is left child. So we want to make its left and right child also. So our root dot left means 4. 4 will be left child of 2. Now root dot left dot right means 5. 5 will be right child of 2. So we have made our binary tree. So for invert tree, I have made a function or method tree node, that is a root, and its name is invert tree. Now we have to make our code. So our first condition will be, if our root node value is null, that means no root is present, no binary tree is present, it's empty. So that in that condition you can return null, and in else part we will write, if there is any root present or any values present, any binary tree present, then you can invert that. So for inverting that we have to swap. So for swapping, our left child value will go at temporary place. So now our left value place is empty. So now our right child value will go at left child place, and then our temporary place value will go at right child place. So now our values are swapped. So now we will return from here root. We are using recursion here, so you have to believe our recursion that it will handle everything. You have to only write its bullet point, means you have to write only main thing in our code. Rest remaining part it will handle itself. So now after that we have to print our values. So for printing we have to make a function, we are making it print tree. Now we have to write its code. So our condition will be, our first condition will be, if root is not equals to null, means there is binary tree present, means there is value present, then you can print our values. So for printing it, we are using in order traversal. So for in order traversal, there is a order. First it will visit our left node, means it will print our left node, then it will print root node, means, and then it will print our right child node. Okay, so for that we are calling this print tree, because we are using recursion, that's why we are calling it. Here also we are using recursion, that's why we have called this. So for this we are printing first our left child, then we will print our root value, and then we will print our right child value. Okay, so now we have to call our functions, our print tree function and our invert tree function, so that we can get our correct output. So for that we are calling this, for calling invert tree, and in input we are giving root. Okay, and this is a variable, it will store this, and then we will call our print tree function. So print tree, and we have given its input this invert tree, so that it can print all its nodes value. So now we will run this and we will see what will be our output, and you will get each and every video link in description box of our Java DSA complete course. You will get its interview questions also. I have taught you each and everything in detail in very easy language in Hindi. So you will get each and every topic link in description box, and you will get playlist link in description box. So we have, yes, our answer is correct, 31524. I hope you understood. And if you like this video, don't forget to subscribe to my channel so you never miss an episode of DSA interview question series. And like and share with your friends and family. Comment. Thank you so much for watching. See you in the next video.